Hello everyone, and welcome to the first episode of this new series I'm going to have called Single Variable Madness. Basically, what it's going to be is that I'm going to be showing you a bunch of these equations that you need to solve for only one variable. Now, usually, single variable equations are pretty easy to solve, like x plus 5 equals 2. Like, obviously, you can easily solve that x plus 5 equals 2 means x equals negative 3. But there are a lot of cases in which equations are really hard to solve even with it only having one variable. Like this case. I wouldn't say it's very difficult, but it can be pretty difficult if you don't know what you're doing. And there's only one variable in this equation, so it should be really easy, but it's going to take some tactics that you wouldn't normally see in a normal equation. So, let's get started. We have 5 to the power of x plus 10 to the power of x equals 20 to the power of x. First thing I noticed is that all of these terms have a 5 to the power of x in it. 5 to the power of x, well, that's just 5 to the power of x. 10 to the power of x is equal to 2 to the power of x times 5 to the power of x, correct? And then 20 to the power of x is just 4 to the power of x times 5 to the power of x. So, what we can do is that we can factor out a 5 to the power of x from each side. So we have 1 plus 2 to the power of x. So 5 to the power of x times 2 to the power of x. You can multiply the 5 and 2 to get 10, and you'll have the 10 to the power of x. You can do the same thing over here, 5 to the power of x times 4 to the power of x. Now we can get rid of the 5 to the power of x. Now, we have 1 plus 2 to the power of x, and that equals 4 to the power of x. Where can we go from here? Well, one thing you can notice is that 4 to the power of x is equal to 2 to the power of 2x, right? Because 2 to the power of 2x is just 2 to the power of 2, which is 4 to the power of x. So 4 to the power of x. Now, how does that help? Well, this is where you can use a really powerful method where you take an equation which only has one variable and add more variables to it to make it easier to solve. In this case, so let me just write it like this. 1 plus 2 to the power of x equals 2 times 2 to the power of x. 2 to the power of 2x. So we have that. Now, let's just bring everything on one side. So let's just bring these terms over to the right side. We have 0 equals 2 to the power of 2x minus 2 to the power of x minus 1. Now, you might notice this kind of looks like a quadratic equation. And if you don't see it, I'll show you this. What if we substitute 2 to the power of x with another variable y? So, let's see, we have 0 equals 2 to the power of x is y squared, right? Because if you take this and you square both sides, you get y squared equals 2 to the power of x times 2, or 2 to the power of 2 times x. So we have y squared over here, minus just y, minus 1. You see a quadratic now, right? So, now, let's just solve it normally using the quadratic formula. So, we have y equals, so negative b, which is 1, plus or minus the radical 1 squared minus 4 times 4ac, so plus 4 all over 2a, 2. So that is 1 plus or minus the square root of 5 over 2. Now you might notice that 1 plus or minus the square root of 5 over 2 looks familiar. In fact, 1 plus the square root of 5 over 2 is equal to phi, or the golden ratio. We won't be talking about what the golden ratio is that much in this video, but basically it's very apparent in a lot of nature. If you take a pine cone and you measure the ratios between the cone, it's not that difficult to explain. If you search up what the golden ratio is on YouTube, you'll find a lot of videos that explain what it is. But basically the golden ratio is 1 plus the square root of 5 over 2. Now what about 1 minus the square root of 5 over 2? Well, there's this actually unique property that 1 minus the square root of 5 over 2 is minus 1 over phi. So minus 1 over the golden ratio. and I'll let you figure that out on your own. It takes some algebraic manipulation, but it's not that difficult to see after some time. So we have our two answers for y over here. Y equals the golden ratio, and y equals -1 over the golden ratio. So are we done here? Are these our two answers? Not yet. We solved for y. We want to solve for x. So let's substitute 2 to the power of x back into y. So we have 2 to the power of x equals both our phi and -1 over phi. So let's just start with phi. So what do we do now? Well, what we can do is that we want to solve for x, right? So we can just take the log of both sides. So remember, taking the log takes this exponent and brings it down. So if we take the log of both sides, sorry, I have to write it a little bit like that. This x goes down, so we get x times log of 2 equals log of phi. Let's divide log of 2 by both sides, and we get log of phi divided by log of 2. And then if you use the change of base, well, let me write it first. Log 10 of phi, we're using base 10 for the log right now, divided by log 10 of 2. Now, if you do know the change of base, you can actually change this into having 2 as the base by making it log, I want to make the logs like that, log base 2 of phi. This is an answer. So we went from here to here because this is basically a change of base formula. If you want to change the log base 2 of phi into a base 10 logarithm, you have to put it like this: log base 10 of this number divided by log base 10 of this number. So we just use the converse of that idea pretty much. So this is one of our answers: log base 2 of phi. Log base 2 of phi. So let's do the same thing for -1 over phi. So we have, let's see, 2 to the power of x equals -1 over phi, phi. However, let's stop here and let's put our pen down because we know that we are actually done. This is not an answer. This cannot be an answer. Keep in mind, 2 raised to any real value will never be a negative number. And sorry, I didn't say this before, x is a real number. So if we raise 2 to any real number, we're never going to get a negative value. So basically, this is not a solution. This can never happen. We can cancel this out. So that means there's only one solution here: log base 2 of phi, or log base 2 of 1 plus the square root of 5 over 2. That is the answer choice for this seemingly okay-ish question. Now remember, there are a lot of equations that only have one variable and where you need to solve for that one variable. But keep in mind, a really good strategy is using another variable right here to make this whole experience a little bit easier. So thanks for watching, and stay tuned for the next episode in this series.